Okay, time here is 1 o'clock. So we're going to start this thing I'm calling Software Sessions. Welcome to the first one here. Hopefully everyone can see and hear me out there. It seems to be going on my screen. Let me know in the comments if I'm too loud, too soft, or whatever. Sort of figuring this out as I go. It is a one-man production team, so thought I'd give you guys some background to start. My name's Andy Maluzzi. I'm an engineer. I mainly write software, working on simulations and those sort of systems. I work a lot in C and C++, so I thought I'd share some of those concepts with folks. There's a lot of people that are usually nervous about getting into C and C++ because of pointers and other things. My hope with this is to sort of demystify it. Hopefully, get some questions answered in there. That sort of thing. I'll do this for at least this week. I'm furloughed from my day job, so I have some time. If there's interest, and I'm continuing to be furloughed, I, can totally pick this up, other days during the week. Just sort of let me know what is of interest to you. So let me get you oriented with where the stuff is going to be for, this sort of tutorial. The first one here is GitHub. Awesome. I see audio is good and you can see everything. So cool. Thank you for that comment. So this GitHub is where everything is going to sort of live. And it's going to be github.com/08maluz/software session CPP. If you're not familiar with GitHub, GitHub is a website where a lot of people keep software, and it uses this thing called source control. Source control is a way where you can save files up into the cloud, or your company might have a local instance, or you might run your local instance, and it keeps a difference of each file. So you can see here I just have a license file and a README up there. I'm using the standard sort of MIT license, which gives you a lot of freedom to just go use this. And I'll be updating the README as this goes. And that's all that's up there now. As soon as today's class is done, the last thing we'll do is I'll show you how I'm going to commit everything up to GitLab or GitHub here for everyone, and get to that. So all the project files will be there from this. The other place that you're probably going to be interested in checking out is going to actually be 08maluz.com, which is probably how you heard about this. This is my blog. I honestly don't do a very good job of keeping it going because I work a lot and have a lot of other projects. So I'm way behind on things. But if you ever want to learn more about me or whatever, feel free to click around. But anything tagged software sessions will have this, and it more or less has the installer for Visual Studio. I hope if you're following along, you've already done that. It does take a bit to install. So if you haven't, start doing it now. You can follow the link right here. But we'll assume that you have it starting into this, and I'll open it up here in a second. I have a quick little syllabus here. Today I'm going to go over sort of the basics of programming in C and C++, kind of more on the C side for the first couple of days, and then we'll sort of shift more into the C++ side on day 3, going over some intricacies there. And then we'll talk on day 4 about networking, because that's probably what you're going to do a lot of. It's a guess, but that's likely a big thing that you'll end up doing. And then the last day is multi-threading. My doctorate's in high-performance computing and a lot of multi-threading, so I would be remiss if I didn't talk at least a little bit about that. And there's lots of places that you can go beyond this. We could talk about Unreal Engine and doing some video game scripting if there's interest. We could talk about Arduino and Raspberry Pi stuff. We can talk about Linux, which in some ways is actually easier to work with than, say, Windows in this case. So, if there's interest going into the next week or whatever, there's a contact page as well on my blog. And you can go there, check that out, and reach out to me. That'll probably be the easiest way to give me any feedback, or post in the chats. I'm going to try and watch that as well, and we'll go from there. So these are sort of the main places where you'll find stuff. Like I said, the software sessions thing up here. Also, if you need books, some people really like having a paper reference. I am one of those as well. I have a couple of links on here to Amazon for some books that I actually have and reference even regularly now. So you can go check these books out and all that. They're not terribly expensive. Of course, if you ever run into problems, you can also Google for things or use Stack Overflow, which are some great websites, and you'll probably see them pop up a little bit later. So That's sort of the logistics of the class. I'm going to go today probably an hour, depending on what the questions are in there, just so people can plan. Tomorrow I'm expecting kind of a lot of questions because a lot of people ask questions on pointers, so that might run a little longer. But my goal is to be about an hour of content and no more than 2 hours of a stream or video. And that second hour would likely be the questions and stuff that folks are asking that would slow us out to that, just to give everyone a little bit of chance to plan. If you can't make it, or if you're tuning in later or whatever, I'm recording this, on YouTube, so you should have everything up there. YouTube has a DVR functionality and everything like that, so we should have hopefully a good reference of that up on YouTube. So we'll go with that to start. So cool. Let's get started here. So I'm going to go and close those tabs. This is how I use Git. I've done a lot of work in Linux. That was a lot of my PhD work. So I use it from what's called a bash terminal. So I can use some commands in here to actually navigate my computer. One of those commands is cd, which means change directory. Tilde is my home directory. It's sort of a shorthand. So I have saved that Git repo already to my computer, and since I'm going to start doing stuff for you guys, I want to make sure I'm on that repo. So I'm just going to start typing it in, tab complete. I'm now in that repo. I can track changes in here, and it'll tell me, so like it says I'm up to date right now. This will likely change throughout, but just so you guys are familiar, you'll see me occasionally jump to this and commit stuff and put it up on GitHub. That stuff will be available immediately as soon as it pushes up to GitHub. So even during this recording, you might see some stuff pop up there, and feel free to try it out or build on it. So now I'm going to go to Visual Studio. So I'm rocking Visual Studio 2017. You might be rocking a different version. This is the Community Edition, so it's free. Has 99% of what we're going to need. So we'll start with that. I'm actually going to turn off my video now because you're probably going to want to focus on the screen, and I'm afraid that my video may or may not obscure part of the screen, so let me just fade me out there. I'll jump back in every once in a while, but we'll go with that for now. And I'm watching the comments here. People still say my audio is good, so we'll go with that. Cool. So we're going to start off by creating a new project or solution. You get to pick where you want to put it on your computer first. So I have the software sessions folder where I'm going to put it here. Actually I misclicked. I clicked open a new one. I actually want to create a new one. So to do that, I'll go to File, New, Project. I'm going to do a Windows Console application in the Visual C++ range. Visual Studio doesn't explicitly call out C/C++, but you can actually run C inside of the C++ engine and that sort of thing. So we'll do this here with Visual C++. And we'll just make a console application. That just means it shows up in a command prompt like this. It's not going to be a very flashy, GUI sort of thing. It's just going to be, sort of a more utilitarian project, and go from there. So we'll do that, and I'm going to switch my repo here to be Software Sessions. Select that folder, and whenever you write software, the first application you usually write is called Hello World, and this is your way to sort of just get something out there. So I will name this likewise Hello World, and we'll mess around with it a bit more. I won't just print Hello World, but that's usually the first thing you do. It says create directory for solution, which I'd really like, and it's already being added to source control, so I don't need to worry about that. So I'll click OK, and Visual Studio is going to do some stuff for me, which is really handy because it's going to set up everything for the most part. Cool. This is the window you're going to get when everything starts up, and I'll start taking you through this window because there's a lot here and a lot to digest, and I suspect many people haven't actually gotten to use the Visual Studio IDE. IDE stands for Integrated Development Environment. So let's start off with a few things. First, it tells us our project name up here at the top. It then tells us our file, helloworld.cpp. It is convention to name files by the type that they are. So if you are using C++, you would name it .cpp. If you're using C, you'd name it .c. And if you're naming it something like, C#, it's .cs, Python's .py, those sorts of things. We also have another type of file that we'll talk about a little bit later today called header files. We would name those .h. And if you're using them in C++, some people like to name them .hpp. Sort of up to you on that naming convention. The next thing here is we actually see the contents of the file, which it does such a great job for us and prints out hello world for us. Mainly writes it for us, which is great. We're going to do it probably a few different ways, but this is one way that works. It gives us some helpful comments here. So if you see the whack whack, which is just slash slash, I like to say whack whack, that is your comments. And anything after them turns green. So if I didn't want this, for example, to say hello world, I just do whack whack. And you'll see it turns green. It wouldn't actually do that anymore. Something else that shows up when I change the file, you'll see that that line became yellow. That's how Visual Studio lets us know that, hey, this file is different, and something's going on here. And then finally, you'll notice that there's a dirty dot, as I like to call them up here, on the actual file name. So this is saying that the file is been changed and you haven't saved it. So if I want to save it and get that to go away, I can do Control S, and then it also turns green, letting me know that it's saved. So that's the file. We have some other helpful things up here. Mainly this bracket over here is going to show us all the functions in our file, and we'll create a few different functions besides main as we go throughout today. All the way here on the right, we have our Solutions Explorer. This shows us all of our files in here, and we're going to have a few things to clean up before we really get going in this. So sit tight. I mean, you can run it right now. It's going to print, well, it won't print anything right now, but it would have print hello world. But we are going to do some cleanup here. I'm not a big fan of the PCH, and I'll explain that in a second. Down here in the lower right, you have your properties window. And this sort of gives you some background on any of the files, gives you if it's C or C++ code, that it's looking at what file type it is, where it's located, that sort of thing is included in the project, it's a relative path, etc. At the very bottom here, you'll see where it says software session CPP. Notice it picked up that I'm in a Git repo and that I'm on the branch master. So if I go over here now to my Git repo and I do git status, it sees hello world. So if I go into hello world's file, I can see that there's a solution in here. I can see that there's another folder. So all this stuff is in there. And I can see that there's lots of fun stuff in here. So before I commit the initial one, I want to clean it up a bit. Like I said, I talked about those pre-compiled headers. And then I'll put this up there, and if you're following along, you can clone it down and be exactly where I'm at, in case you're struggling. So far, I'm not seeing a lot of comments, so I'm assuming everyone's doing okay. But if you have any issues, feel free to shout them out in there. So like I said, I'm not a big fan of this PCH. And what is a PCH? PCH stands for precompiled headers. So the idea of this is basically to put stuff in these files that don't need to be recompiled often. And this is a Visual Studio optimization to make your computer build faster. For the apps that I do, I generally like to have a little bit more control over the build, and I often do want to rebuild things because I have like date timestamp macros and stuff like that in there. In this particular case, I'm not a big fan of them. You may love them. I just don't. Usually you want to put your standard libraries or stuff in there that you don't want to have recompiled all the time. So I'm going to actually remove them. So I'm going to delete it from the file here. There we go. And I'll remove this from the project. And it gives me the option to either just remove it or delete it. I'm going to delete it because I'm not going to use it. And likewise with this one, I'm going to remove it from the project and then select the delete. Now this is not going to build properly because I changed some things. Now we actually have to go into the build settings. And this is where C and C++ probably gets the most tedious. And you can spend hours digging through these settings. We'll just touch on a few of them over the course of this week. So I'll go to Properties. And you'll see here in Visual Studio we have two main types of applications. We have Debug and we have Release. And we can target Windows 32 or x64. I'm running on a 64-bit computer, so I'm going to use the 64-bit. And then I have the Debug one up here. This home page here, sort of the general page, tells me that I'm building an application. That's .exe. It tells me my character set, tells me what it should compile out to, where it should save. Lots of information like that. On the debugging, it can tell you if you want to attach a debugger, how you want to do that, all those sorts of fun stuff. And then it'll give you directories. We'll want to go under the language-specific tab, so this case C and C++. And we can actually click through here, and you see that there's one called precompiled headers. And you see that it says use precompiled headers. And I'm just going to say not using precompiled headers. I'll select apply. I'll change my mode to release. Select apply. So it should be correct now in debug and release, which is great. I'm also going to do it for Windows 32, even though I don't intend on compiling a 32-bit application here. I'm still going to do it just to be complete in case I have to later on. There we go. And that's the only real option that I need to worry about right now. There's some other ones like optimizations for speed and all that stuff that we can spend hours and hours just digging into itself. Suffice to say, for what we're going to be doing, you don't need to mess with much of this. We might come back here later to look at things like OpenMP for doing some parallel computing. So you might be turning on multi-threading and that sort of thing. You might be turning on a few other small things here or there. But yeah, overall, we're not going to be digging around here too much. But just a good, here you go, multiprocessor compilation, and there's actually another one called -openmp. So there you go, /mp. And go through there. So, stay tuned for that, but we're not going to dig too much into that. This should be enough right now. I'm also going to go uncomment these lines that say hello world, and I'm actually going to put what's called a breakpoint, and you'll see this red dot here on the screen. This means that the application is going to stop whenever it gets there. Just for debugging purposes. I am going to add one other line of code, and then we're going to talk through it here. I'm going to add return 0. And we'll talk through this. When you see a function like this up here, int main, this int out in front says that I'm returning an integer data type. So without putting some function or some value being returned using the keyword return, that would be technically an error. And you'll actually see that during the compile. It'll say, you did not specify a return type. I'm blowing up on you. So I'm also just going to clean up some of these comments here. I don't need them, and we'll probably talk through them anyway. So there we go. I'm going to set my build to be 64-bit. Looks good. Debug is fine because I'm going to be using the debugger, and I'm going to click build. So let's see if this works. I'm doing this live, so it may not, but cool. Okay, so a few things happened. First, we saw this command window pop up. This is where the application's actually going to do its thing, which is really nifty. Fortunately, we aren't doing anything right now, so we're not going to see anything on that screen. The next part that we're going to see is this is the debugger. So the debugger changes your Visual Studio IDE and pops up a few things that are really helpful for you. So you can actually step through lines. So if I want to step over, step into, that sort of thing, I can just continue running, which would run until the next breakpoint. I can stop debugging. It tells me how much memory I'm using, how much processor I'm using, that sort of thing. And then it gives me a call stack. This is really helpful when you're trying to figure out a problem later on in debugging. And that sort of thing, as well as it gives me the ability to watch variables. I don't have any variables in this application, so it's naturally empty. I can also look at my output window, which will tell me all sorts of information. So it couldn't find or locate a PDB file, so it's looking for a whole bunch of Windows directories here because it's actually going to be loaded IO stream and it's going to be printing out something. So it looked for PDB files, which are essentially their debugger file. So if you get these warnings, it's not the end of the world and that sort of thing. So I'm just going to step through this. So I'll step over. It said hello world. And if we go to our command window, we have it saying hello world. We've successfully written, a C or C++ application. It does something. The next thing it's going to do is we're going to return 0. And down in our return stack here, it says the thread executed with code 0. So we successfully completed our application. We can click the continue button and we exit out. And there we go. We exited with code 0. So that means our application worked. We did something really cool. We made it actually print something to the screen. Yay, we are now all C and C++ masters, right? Not quite. Like in any language, there are ways to do things. There are multiple ways to do things. So one of the other things we can do is we can include a different way to print out text. So including a library is like saying, hey, this is a function that I want to try that someone else has already written. So one of them that's very common is standard IO. So stdio. So to do that, we would do pound include, and then bracket stdio.h. So remember I mentioned that h is a header file. So we see here that we have standard cout, which is our console out, and we use these two arrows to send the string, hello world, string being how we store text, hello world to standard out. And we put /n on the back here. This is actually a special thing that's a new line, and instead of just displaying the /n, it just puts that out. We can do something else though, cool, and this you might be more familiar with if you've programmed in different languages, printf. So printf does the same sort of thing, I just gotta give it a string. So in here I might say, this is on a different line. And then every line in C and C++ ends in a semicolon. You can put down semicolons sometimes as well, just as debugging points to be like a no-op and that sort of thing. So I use those a lot. But yeah, now I'm going to want to also end this with probably a new line as well, just to be nice to me later, because I'm probably going to want to print something out and forget about it. So it's helpful to just have it end with a new line. So you'll see we have our dirty dot, and you'll see that we have some yellow dots here where things have changed. I'll save those, saves it to the file. Here we go. We should get our window open here. I'll step through the first one. And you'll see I said hello world. I'll step through the next line, and you'll see this is on a different line. So this is two different ways that we can actually print text out to the screen, which is really useful. And I'll continue and finish this out. So we have a really simple working application right now. So I'm going to hop on here, and I'm going to add things. I'm going to add hello world.cpp. I'm going to add the project, and I'll add the filters. And I'll add the solution on here. I'm not going to add anything in the x64 directory because that's compiled, which means it's a binary file, and Git doesn't do a good job storing those. It actually has to copy them every time. So in order to just get this up there for folks, we just want to save the text files, and then you can build it locally. So git commit. There we go. And I will put that up there. So I've committed it, and now I just got to push it. And it has now pushed it up to GitHub. So if you are watching this now and you go to GitHub, let's pull this over here. GitHub/me. You'll see that, there's my post. Or somewhere in here is going to be that post. There it is, right there. One contribution today. I can go to my repositories, software sessions, and you'll see hello world is up here with our comment and all that. And that was literally just posted a few seconds ago. So if you want to pull that down, you have that now at home. So I'm going to check the comments here. I haven't looked at them in a second. Make sure I'm not missing anything. See a few people over there that no new comments. We do have folks watching, so it's cool. And it says that my stream is in good health, so cool. I'm just making sure I didn't miss anyone. Okay, so now let's start making this function, or this hello world, a little bit more complicated by adding another function. It's really sort of easy to write one long function that does a whole bunch of things, but it gets hard to maintain it, and sometimes you want to use functionality over and over again. So if we start thinking about functions as a way to sort of reuse logic and potentially call them several times. So in this case, in the hello world, maybe we want to save that line that says this is on a different line and do that printing like 5 or 6 times. So let's dig in there and see how that goes. So I'll jump back over here, and I'm going to create a new function here. I'm going to say void. Void means we don't return anything. Print on new line. And I am going to just put what we call the declaration of the function above. In C and C++, you have to define everything before you call for it. So in this case, by putting that particular line before our main function, main can use everything that we define up there. This is pretty uncommon in other languages. If you're used to Python or C#, you can sort of skip this, and it's the compiler and everything's smart enough. C and C++ requires that you either define the function before you use it, or at least put the declaration up there. This actually even underlines it with the green squigglies and says I can either create a definition of it, or I can copy the signature to a clipboard and that sort of thing. I'll actually take it up on the copy it to the clipboard, and I'm going to put it down here, and I'm going to open up a curly brace and do that sort of thing. Now, I personally like my curly braces on new lines. You may be different. So I am going to then steal this particular line that says this is on a new line and put it in that file. There we go. And I'm going to call print on new line, and you can see the IntelliSense here in Visual Studio already picks it up for me. We can call that and put our semicolon at the end, and it will actually solve that, or call that function. So now if I go to run this, we should get the same exact output as we got last time, but our debugger will behave a little differently. So let's actually run this now. So I'm going to jump over the first one. We see our hello world. But now this print on new line, I'm going to use the step into, which is the F11 key, or you can click the arrow. And it's actually going to jump. You see the arrow here jump down to this function, and it's going to print on a different line. And we'll see it does the same exact thing. And then we'll keep following that arrow, and you'll notice it jumps back up to our main function to return 0. So that's a really nifty way to just sort of reuse something. And maybe we want to call this now 5 times. There we go. And we can go through here, rerun it. Look at that command line that popped up, and we can go step on it a few times. You'll see it keeps printing it over and over again. Handles all that logic for us, which is really nifty. Maybe we want to make our printing be a little bit smarter. Like, I'd like to know how many times we've printed print on new line. So I'm going to say we have called this percent lowercase d times exclamation point. And I'm going to create what we call a global variable in this case. So this would be an integer. Well, we'll make it a unsigned integer. Just because we can't call it negative times, right? And we're going to say this is our call counter. And we'll start our main function now off with being the very first thing is going to be set call counter equal to 0. So that's going to set whatever this value is to 0. C and C++ will typically initialize functions, or sorry, not functions, but global variables to 0 for you. But I like to be very, very explicit, especially because a lot of the software I write, more personally than professionally, but conceivably can be built using different compilers and run on Linux or run on Windows or run in different operating systems. So I like to be very explicit because not every compiler and operating system assumes the same thing. And just taking that little bit of time to say, okay, yeah, it's equal to 0, it doesn't impact performance at all, and it just makes things a little bit easier when you're trying to debug later. So I highly recommend doing that. So we'll do that there. And then in our lower function here, we'll say call counter plus plus. So plus plus is a shorthand in C and C++, and really in a lot of languages. It just means increment 1 to whatever that variable is. You can also do minus minus, and that's just a nice little shorthand to do that. So what our code's going to do here now is it's going to set call counter to 0, print hello world, and then every time we call print on new line, it's going to increment call counter. We have one last thing that we're going to want to do with this. Remember that %d that we put right here in our function? That %d, So I have a question here asking, did I type void in the print new line function since it does not return any variable? That is correct. So because we don't return anything, it is void, and that's common in some languages. We might tweak that a little later and make it return something, but yes, void just means that this function does not return anything. So thank you for the comment there, Andres, and hopefully that answers that for you. So here's call counter, and call counter has this %d like I said in here. This %d means it's another like keyword sort of thing, sort of like that /n, and that means that we're going to be looking for a number. So to indicate that there's an argument now to this function, printf, I can do a comma, and then I can give it, in this case, call counter as a variable. Now, if I was working with this standard out, standard C out here, I could also just use arrow and pass it the variables and do things sort of that way. I personally prefer to use printf. I prefer thinking of things functionally, and that just sort of makes it a little bit easier for me to debug and to understand. But you know, code style might dictate that you do it a different way. So you can definitely do the same way with standard C out. But I'm going to do it with printf just to keep things simple. So here we go. So let's go and run this function. Okay, so if we look down here now, we have a variable in here, and I realize that you can't see me, or you can't see it because I was there, so now we're in debug mode. We have a variable down here called call counter, and it has an initial value of 0, and it has a type of unsigned int. So we're an unsigned integer. If I go now into print new line, you'll see that still value is 0. We printed our hello world. If I step over the first one, though, you'll see call counter is incremented. It has a value of 1. And if we look here on our, our output, it says we've called this 1 time. Now, if I step into it just so we can see what it's doing here, it first will actually increment our call counter. You can see that on this line. And then it will print it out on this next one. You'll see that it already had the value of 2 before we called this printf. So that's something that we can learn from C and C++, is that it is a sequential programming language. It is every instruction happens in the order that you put it on the stack. And that will be a little different come Friday, but at least right now will give you sort of the ability to sort of think through things and say, do this step, then do that step, then do this step, and hopefully make life a little easier as you start writing simple programs. We'll keep going on this now, and I'll just jump over them. And you'll see that our call counter keeps incrementing in here. And it keeps going up, keeps going up. You can see call counter there, incremented to 4. So, and ultimately, it went all the way up to 5. And we can see that here in our function. So cool. We have now used a global variable to to change and grow, as well as we've called the function now to reuse logic over and over again. We could do the same thing if we did call counter and printf. So I'm just going to finish this out. If you've used any sort of programming language, the next sort of concept that we're going to talk about should be pretty familiar to you. And they work pretty much the same here in C and C++, is this idea of a loop. So rather than calling the same function several times, we might want to create a loop. So to do that, there's 2 different types of loops really that you can use. There's a few others, but for simplicity's sake, we're going to figure there's 2. We're going to use a for loop. The other type would be a while loop. And basically a while loop says, while some condition is true, execute everything in that loop. A for loop says, do this a number of times. And you can sort of tweak and expand on those to go in different ranges, different ranges and different functionality. That's a bit outside the scope of what I'm going to be covering in this tutorial, but that's sort of a good starting point. And we'll start with a for loop because generally a while loop can lead to some undesired behavior. You can get into what's called an infinite loop, which can sort of just make your program stall and keep running forever and ever and ever. And it's probably not a good thing. So we're going to go through here and we're going to make a for loop. So to do that, I'll create a new line. Actually, before I do that, because this is probably useful to people in its current state, let me get this up on Git for everyone. So I'll use git status again just to see what I've changed. I've only changed one file. So hello world, stroke hello world dot cpp. Added. Commit messages are always helpful. This will really be helpful too if anyone goes back later and wants to review this and sort of catch up and follow along. So I will do that. I will push this up and make sure everyone has that. Perfect. So if you're following along and you need to catch up, you can pull this down now from GitHub. Cool. So we're going to use that for loop, like I said. So I'm going to create a new line here. I'm going to do the word for, then open parenthesis. So it's sort of like a function in that way. I'm going to say, we'll say char. Char stands for character. You can use it like a, it can either be like a letter, like a character in a sentence, or it could be a number. I'm going to use it like a number here. What's more important about the keyword char in C and C++ is that it's usually mapped to a data size. Typically, it is 1 byte in size, but that can change based on your architecture. But generally speaking, a char is going to be 1, maybe 2 bytes. On the Intel, x86 or x64, it's going to be 1 byte, so it's a good small size. The big advantage to using C and C++ is being fast and being efficient. So being prudent with your memory choices and packing things in there is really, really helpful. So I tend to try not to make things bigger than they need to be. So I'm going to say this char, call it I, just because it's going to be incremented. I'm going to say it equals 0. So the first sort of part of this for loop is we declared a new variable, I, and we set it equal to 0. Then I'm going to say while I is less than, we'll say 5. Let's keep printing it 5 times, because that sounds like a good idea. And then we're going to use that plus plus thing that we did before. We're going to do I plus plus. So the way that this works is it sort of says the initial conditions, which is that char I equals 0, which you see here. This is the initial conditions when the loop starts running. And then the comparison it makes each time it does the loop. So a for loop is basically an implementation of a while loop. And then what happens at the end of the loop. Once it's done doing its thing, it's going to increment those values. So I will go here, put down some brackets again, and I will just cut one of our print on new lines, put it up there, and delete the other ones. There we go. And I'm going to save this, and I'm going to run this. So here we go. We hit our breakpoint again, hello world. So if I step over that, we'll see hello world just like we did before. But now we called into this for loop, and you'll notice that we have a new variable down here. It's actually a local variable. So the keyword local means in the scope of that function. So the variable I that we have for this loop can only be seen inside of those brackets of the for loop. The function print on new line cannot actually see that variable I, at least not yet. We'll show you how you can pass that variable around in a little bit. But right now, it can't see any of that. So it's just going to call this function, though. There we go. It called it once. And if we go back to autos here and we go back through and I step into, you'll see that I goes away, but call counter is still there. And there's no locals on this particular function. Just we increment call counter. And you'll see that it actually runs this same code several times. So there we go. You'll see it shows both the global and the local here, but if I go to locals, I is the only one shown. And if we look here at the screen, it's showing the exact same thing. Now you'll notice it ran its 5th time, but the arrow jumped up to the top. That's because it has to do this condition, this comparison here, to decide if it's going to keep going or not. So I bet you I says its value is 4, and then it incremented and it did its comparison, such that I was probably then 5. And then there we go. We're on our return 0, and our function is complete. So that's adding a simple for loop to this logic. So pretty simple. Maybe, though, we don't want to use the global necessarily, or maybe we want to have it print and keep track of how many times it's called that function. So we have call counter that, will say how many times we've called this print on new line, but maybe we want to have it say instead, we have called this function, let me pass in an integer. So we'll have to define it up here. So we'll say unsigned integer value. And I need to update my actual declaration here as well. There we go. So we save that in both cases, because these both have to match. I don't have to have this line here, remember. I could put this entire function before the main, but generally speaking, folks find it a little easier if you go first to your main function instead of having to dig for it at the bottom or in the middle of the file. It's usually easier to, just know where it is in the front. So I like to, keep these declaration lines there. And now I have this new value. So we're going to keep incrementing call counter, but I'm going to put in here a new one, value. Now value might be different than call counter. So when we go to call print on new line now, we can actually pass in a value. And let's say we want to pass in the value I, but we really want it to be, we'll start with I, right? So let's go ahead and run this and see what happens. So we're going to go and step over things here a few times. And if we look at our thing now, we start at 0. We don't start at 1. If you remember, call counter started at 1 because it increments before here. And if you look at our values here, call counter is actually ahead of I. Well, the reason why that happens is we're passing in this value, this value of I, which in this case is going to be, if I go and increment here, it's 2 when it goes in. And if I go and I step into the function, sure, call counter is about to get incremented to 3, but the value that we print here is actually that value 2 that we passed in. So this is how you can sort of communicate between functions and make that reusable. And we can have lots of different parameters to do this. So I can click through this a whole bunch of times. I can put another breakpoint here on return and just hit continue. And you'll see that we count 0, 1, 2, 3, 4, which is a pretty common way to count in terms of computers as you start at 0. So. And that's how that worked, which seems to be, doing exactly what we expect, which is pretty cool. We can also be kind of wacky with this. So maybe we want this to be I plus 7. You can actually put an argument in there or some math in there. So if I go and I rerun this, and I'm just going to jump straight to the second one there, you'll see that we start 7, 8, 9, 10, 11, which is kind of cool. We can also be wacky and say we want to put value here plus call counter. So you can even put a an expression as an argument to printf. And if we do this, I'm going to just jump right to the end, things get really wacky. So you see 8, 10, 12, 14, 16, so it counts by 2. And the reason why this works that way is the values that you put into these arguments get evaluated before the function is called. So it's just like if you remember in middle school math, you learned that things get executed in the parentheses before anything else. It's the same exact concept there. What we do in these parentheses gets done first and then passed in. And we can mix values between local and global values when we want to compute something. Nothing says they have to be the same. So that's one way to exchange that information. I'm going to go back and simplify this down, just in that case. And Andres had asked before about that void character, and I'm going to change that void to be a int. I'm going to put it here as well on this function and call it an int. I need to stop my debugging, otherwise it's going to yell at me. Now I need to actually have a return function on here. And maybe I want this to return the negative call counter. So to do that, I can return just a negative, -1 times call counter. So I can return a function as well. You can do it with math, or you can just straight up return the values. And maybe I want to put in here a local integer. We'll call just return from function. Just so everyone's aware of what you name these variables really doesn't matter. You can usually do camel case or, I like camel case. I generally, when I start getting into C++, I will sort of have a more defined code style. When I'm doing something small like this, I'm a little more just sort of get her done. But usually functions, if they're in a class, like a class would be capital, public functions would be expressed one way, private functions would be expressed another, and we'll get into what those are later. But all of that stuff is something that I would, I'll probably go into more on Wednesday in terms of code style. So for now, if you're a big code style person, you can scream at the screen all you like. But otherwise, we'll just sort of keep it informal here. So, but now we said our print on new line function, in fact, returns a value. Going back to Andre's question here, we return an integer. And in this case, I am going to say returned from function minus equals. Or we can even do plus equals, doesn't matter. Doesn't like the text there. We're going to increment it. Again, I like to be also explicit, so I'll set this value to 0 just to, And then I'll make our, there we go. Instead of returning 0 every time, we'll return what we return from our functions. Just to be ornery and different, right? So let's build this up. Also, when you click the build, it will autosave, in case you haven't seen that yet. So if we look here, we have our local variable return from function, and it's currently 0. We'll step into things here. And return from function is now -1. Cool. Run it again. It's now -3. Call counter is 2, so -2 times 1 is, sorry, -1 times 2 is -2. So we'll see here that we sort of have a negative factorial thing going on here as it grows. And ultimately, we'll get to this return from function, which is now at -15. Maybe not factorial, but similar in concept. It sort of grows like that. And if we look here at our application, we can see our times, 7, 8, 9, 10, 11. That's still the I plus 7 still goes on. There we go. And then click through, and we're done. And we'll see down here that the program exited with code -15. Sort of convention is for if things exit cleanly to return a 0, and if they don't return cleanly, you can give them an error code. You can look up in your operating system or your coding style what things need to be. For the scope of this, I'm just having fun with it, so we'll return that. So there we go. So now we've added some loops, and we've added some local variables, and we've played with passing and returning values from functions. So I'm going to go and save this now. It's been a little bit, I think, since we've done that. So I can use the up button in this, which is wonderful, to just sort of go to the file I changed. So added add local variables and set up functions to take and return values. Cool. And that's now up on GitHub, so if anyone is joining late or whatever and wants to catch up, you are now instantly caught up. So, cool. Now remember, I said we can take as many things as we want in terms of values in these functions. So maybe I want to put in here an int that is my fave number. And I just got to copy that and put that down here. So now I can pass in my favorite number as well. And I can make up this number. So it's going to say that expected type qualifier. It doesn't need one. So the comma here basically is a way in both, commanding an argument, or when you declare a function as well as when you call a function, indicating the different values that you want to put on there. So if I want to say my favorite number, which we'll say is 3, I can pass that in. And then maybe I want to increment call counter by my favorite number and just be really ornery like that. So I'll say it is plus equal to, not 3, sorry, my fave number. There we go. So even though I set it to 3 up here, we want to pass it in as an argument. So we'll go ahead and we'll run that. And if I step into this function here, and I go to call stack, you'll see here that it actually tracks all these functions that are being called. And this is really, really helpful in debugging. In fact, this is like the go-to thing that you want to see in debugging. As it says on line 17, we called print on new line, and it gives me the argument. So that tells me what function I'm in. In our simple application like this here, where we're just sort of playing around, it's not a big deal to try and figure out what's going on. But if we're nested down like a dozen different layers in terms of code, and you're trying to figure out where a bug is, it can be really, really helpful to have a call stack to sort of debug that. Also, you can track where your breakpoints are over here. Any exceptions, right now I don't have any of them that are going to pop up because we're doing something so simple. You can also see like your regular command window. And this would be like commands that I can issue to the actual Visual Studio IDE. It's not like Windows commands per se. Your immediate window also is commands like that, and then your output. So, yeah. And then, of course, we still have our hello world over here. So if I go and I click through this, though, a few more times, and I'll just leave the call stack up here just so you can see it. So the call stack, you'll see changes depending on where I'm at. So if I go into this function, you'll see it got a little bigger. And it stays that same big size as I go through. So cool, I will get to the end. It tells me that I'm at line 19 with a breakpoint. And if we look at this, here it still counts up the same. But then if we look here, it says my return value is now -45. And that is because I have been using my favorite number instead of just incrementing our call counter. So call counter has gotten really, really big. So there we go. And we can step on through, and it will return that as an output. And you'll see down here, we exited with code -45. So there we go. We've gotten through, loops. We've gotten through, different, logic and all that, passing functions and all that. There's really one last topic I want to cover here, and it's good because we got about 7 or 8 minutes here coming up till we're at the 2 o'clock hour. And that last topic is going to be conditionals. So what makes our program smart? So to make a program smart, one of my, the way that we would do that is with an if-else statement. It's generally good practice to always have an else on your if-else statements, just to sort of handle any leftovers. You can sometimes just get away with an if to be quick and dirty, but I like to be very explicit, as I said earlier. So what we're going to say here is if, and let's say we don't want my favorite number to be a negative number in this case, because it could be, because we declared it just a regular int, not an unsigned integer. An unsigned integer can go from like 0 to some really big number, 32 bits, so really big, as where an int can go from negative half of that size, negative 31 bits worth of information, to positive 31 bits of information. So why don't we say if my fave number is less than value, just to be different, do something, else do something else. So we'll say, how about call counters equal to, so if my favorite number is equal to or greater than the value that's coming in, it will do this particular function. And it'll call counter plus equals my fav number. Otherwise, how about in this case, call counter do minus equals my fav number. Super simple, right? We'll just take away the +7 here too, just to make it a little different. So this is just a simple, if this statement is true, execute this line of code. So if we say if our value coming in is 0 and my fav number is 3, well, is 3 greater than 0? Yes. So then we're going to run this code down here that says call counter plus equals my fav number. But let's say the value that we put in here is 4 and my favorite number is 3. Call counter is going to execute this line saying that it is going to subtract 3 from it. So when you do an int instead of a void, it means that you need to return an int, correct? Yes, that is exactly correct. Yep, that is 100% correct. If I put an int there, I have to return an int. I could put a string, I could put a char, I could put something else. I have to return something of that type. But yes, a void means you don't return anything. But you can still actually call return. Return is a nice way to exit a program. And I'll show you a little function that does that here too before we go. So I'm going to put a breakpoint on this just because I think it'll be fun to use our debugger. And this is a lot of times how you'd use a debugger is you'd put the debugger on a block of code that you want to see when it gets hit. So here we go. I'll run it. We see we got our hello world. Now I want to go to the next breakpoint. Now, as we've been doing this, it's been this sort of return function. But I bet you we're going to hit another breakpoint instead. Yep, we hit this one. Now, if you notice, it jumped all of our values. My call counter is 12. So we've been doing a whole bunch of calls down here. And if we look at our value, it's 4. And my favorite number is 3. So we actually hit that. So I got another question here. Unsigned means that it can't go to -1, just 0 and above. Yes, that is also correct. Yep, that is also correct. So if it's unsigned, it's a positive number, 0 and up. Good questions. So let's see here. We then execute this particular function. We still print out our value. So what the user sees is all still the same, counting from 0 to 4. And then we finally get to our return function, which in this case is -39, because it's been summing up all of those values. And we can exit out. Cool. So I promised you that we would talk about returning in a function that doesn't have to return. So I'm going to put one in here. We're going to make another function. We'll call it void I quit. Can't put an exclamation point there. But an I quit will take a int. We'll just call it value. Here we go. And let's define I quit down here. We'll say if value is less than 0, we'll say, do something, else do an else if. So an else if is basically like linking multiple if statements together, which is cool. And then else would be pretty much anything else. But let's say in all this we also just want to make sure that value isn't the number 7 for some reason. So we can say if value equals, which in this case we use a double equals in a comparison, the number 7, say maybe we're going to print f printf that shouldn't be that, and we do return. And then in this case, we'll say call counter plus equals to 2 times value, call counter plus plus, and otherwise we'll say, call counter, or printf, we'll say. And I'm actually stringing together, oops, I bumped the return key there. Stringing together a bunch of those commands. The %d is to print the number. The n is the new line, so I got to give it the number, call counter. So basically this function, so say if we're equal to 7, we say the value shouldn't be 7 and we leave. And then we say if the value is, less than 0, we're going to make call counter get really big. If the value is greater than 10, we're going to make call counter get small really quickly. If value is greater than 10, we will increment it. Otherwise, it will just print out what the value of call counter is. So that's the function iQuit. And in this case, we could put, iQuit and base it on the return from function plus 7, or make it up like that. And then just to illustrate it quitting early, I'll put it up here as well. There we go. So this is going to show how that void can just return, and it also shows us how we can do an else if and link a couple of ifs. And this is the last little thing we're going to play with today. And I'm going to add some comments to this code so everyone can follow along. So here we go. We call iQuit. We go in here, and we say if value equals 7. We're going to print, and then we return. So the function is done. So that is one way that you can return void, essentially. Then we go into our for loops. We hit iQuit again. Actually, don't know what the value is coming in. It's not less than 0. Up. It just tells us to print the value of call counter, and we can loop through this a few times. And we can see then it only called the value of call counter once, and I guess we'll just sort of keep it going. Here we go. And here's the value of call counter. So it ended up calling that particular area, hit this else statement a total of 2 times, which is cool. And there we go. And we'll return out, and we'll see that we have an exit with code 3. So we exited with a positive value, which is cool. So that's how you can use this return to sort of exit like that. So that sort of completes what I want to get to today in terms of content. What I'm going to do now is I'm actually just going to leave the stream going, see if there's any other questions that pop up, and I'm going to go through here and just comment it using that whack, and go from there. So and then I'll commit this up to GitHub in case anyone else wants to follow along later. So it's just a little bit of a confusing program to sort of just get us thinking. So here we go, and I'll keep watching the chat. I see a majority of folks dropped off, but if there's anyone still watching and has questions, I'm still here. Cool. There we go. I added comments there for each line. And I am just going to throw this up here on Git. Oh, thank you, Michael, for watching. There we go. And push that up. Cool. Oh, there we go. I have that pushed up. I'm going to make a new blog post for anyone who's still watching or watching this later. I'll make a new blog post with the link to the next video for day 2. I'll get that up there now. And otherwise, I'll catch you all tomorrow. Hopefully this is of interest, and feel free to let me know in the comment section of my blog if you have any suggestions, any comments or anything. And thanks for everyone for commenting in the chat. I'll catch everyone later. Thank you.